to Physics Unit 1.2 on dimensional analysis. The objective is to be able to identify units and perform a dimensional analysis of displacement, distance or position, velocity or speed, acceleration and or time to achieve a consistency of units within a problem. So the definitions are dimensional analysis in engineering and science is the analysis of the relationships between different physical quantities by identifying their base quantities and the units of measure and tracking these dimensions as calculations or comparisons are performed. That's a really heady answer. i.e., that means converting one set of units into another. So looking at the units, remember that distance, displacement, length, those are all standard measured in meters, but you'll also encounter them in feet, and miles, and inches, and centimeters, and kilometers, so on and so forth. Time is generally measured in seconds, but could be in hours and minutes and years and days, so on and so forth. Speed and velocity are usually in meters per second, but could also be in miles per hour and feet per minute and so on and so forth. Remember that speed and velocity are a distance measurement over a time measurement. Acceleration is generally in meters per second, but again also remember that acceleration could be given to you as miles per hour per second. You just have to be able to match all of the units up. So you need to be able to convert dimensional analysis. So here's your method. Dimensional analysis is the process of converting one set of units into another. And you're going to set up a series of multiplied fractions where mathematically you will multiply across the top and then divide across the bottom, canceling units out as you go. And I'm going to walk you through 3 problems. This class will operate between metric and standard. So when you set up a table, you start with what you know and the appropriate transitions to get to what you want. Then you fill in those equivalent values in one mathematical step. If you have a calculator like I told you to, you're going to multiply across the top and consistently divide across the bottom. So on a formula sheet, you need to add standard unit equivalents. New box, this would be box number 5, I believe. Standard unit equivalents. 1 kilometer is 1,000 meters. 1 meter is 100 centimeters. 1 mile is 5,280 feet. 1 inch is 2.54 centimeters. 1 foot is 12 inches. 1 minute is 60 seconds. And 1 hour is 60 minutes. Those are the only ones that you will be using in this class. Now, this is a sample problem just for video purposes. If an object is traveling at 8.96 meters per second, what is its velocity in miles per hour? And again, I'm going to walk you through this one, but then we're actually going to do 3 together. So you have to set up a dimensional analysis to convert meters per second into miles, here's your miles, per hour. Okay, so mathematically it will be 20.04 miles per hour. Okay, let's walk through several examples together. What I need to do here is I need to insert a chart. Insert a table. And I always start with a 6x2 table. And you start with 32 feet. And based on your conversion chart, your standard unit equivalents, your feet would go on the bottom to cancel them out. And feet will turn into inches. Your inches would go on the bottom and would turn into centimeters. and your centimeters would go on the bottom, turning into meters. Now, I don't need these last two boxes, so I can delete them or just leave them there and leave them blank, because meters is what I'm going to end up with. So based on the instructions, the method, once I have my units in my dimensional analysis, now I need to input the correct numeric relationships. So 1 foot is the same as 12 inches. 1 inch is 2.54 centimeters, and 1 meter is 100 centimeters. Okay? Then mathematically, in one step, I'm going to take (32) times 12 times 2.54 and divide by 100. So on a calculator, 32 times 12 times 2.54 divided by 100 is 9.7536 meters. 32 feet is 9.7536 meters. Let's do another one. 47 hours is how many seconds? Okay, so again, I started with a 6x6 grid, and I'm going to start with 47 hours, or 6x2 grid, sorry. I'm starting with 47 hours. I'm going to decrease this font just slightly so that it's easier to see. Based on my equivalent chart, hours turn into minutes and minutes into seconds. So my hours goes on the bottom, turns into minutes, and then my minutes go on the bottom and turn into seconds. That's all I need for this one. Then you put in your number equivalents. 1 hour is 60 minutes. 1 minute is 60 seconds. And then mathematically, you would multiply across the top 47 times 60 times 60. There's nothing to divide here because you're dividing by 1. So 47 times 60 times 60, grab your calculator. 47 times 60 times 60 is 169,200 seconds. One more. This one you're converting a velocity. So notice here what I'm about to do. I have 14 miles per hour. So the miles are on top and the hours are on the bottom. Now, you're going to tackle one of these at a time, either miles or hours. If you tackle miles first, you're going to put miles on the bottom, and miles, according to your chart, turn into feet. Feet goes on the bottom, turns into inches. Inches goes on the bottom, turns into centimeters. Centimeters goes on the bottom and turns into meters. Meters is my top goal, so I want it to be on top. Then I actually need to insert another column, because now I have to go all the way back to the left, to the beginning, and get hours. And it's on the bottom now, so I put it on the top to get rid of it, to cross it out. Hours turns into minutes, and minutes turns into seconds. That's the unit relationships. Now I go and get the equivalent number relationships. 1 mile is 5,280 feet. 1 foot is 12 inches. 1 inch is 2.54 centimeters. 1 meter is 100 centimeters. 1 hour is 60 minutes. And 1 minute is 60 seconds. Then mathematically, you multiply across the top and divide across the bottom. Now it is vital that you get this correct. 14 times 5,280 times 12 times 2.54. Then the rest of the top is ones. We don't care about multiplying by ones. The bottom starts with ones. We don't care about those either. Then you're going to divide, and this is all one step in the calculator. Divide by 100, divide by 60, divide by 60. On my calculator, 14 times 5,280 times 12 times 2.54, divide 100, divide 60, divide 60. Then hit equals. When you do that, you should get 6.25856. We'll talk about rounding later. All right, you're going to do dimensional analysis problems today. Thanks for watching.